All right. Hello, everyone, and welcome to the stream. I hope everybody is doing well tonight. We are going to be doing some new stuff tonight, picking up where we left off last time, but also moving in a new direction. So we'll talk about that here in just a second. 10x Developer, you are first. Hello, how are you doing? Capuche, good to see you as well. Apotham, of course, good to see you as well. Welcome. So before we jump into what we're going to do in the stream, I do want to just take a quick second to thank the supporters of the channel, starting with our elite partner, Javier Lazaron, followed by our partners, Gerbolis Inc. and Matt Osgard. They are the highest tiers of subscription over on YouTube memberships and Patreon, followed by our supporters listed here on the screen. They are a combination of the other tiers of support over on YouTube memberships, Patreon, as well as Twitch subscriptions. All of these, all the funds from this, rather, help support the channel and cover the costs of running it and cover things like hosting fees, software licenses, things of that nature, and are appreciated a great deal. So thank you very much for that support. I really do appreciate it. And of course, I would also like to extend a large thank you to all of you, the viewers, whether you're joining us here live on the YouTube side or the Twitch side. I appreciate each and every one of you guys. Thank you so much for being here. Without you guys, this channel and this project would not exist. So I appreciate each and every one of you guys. Thank you for being here. Psycode, good to see you. First, yeah, not quite this time around. Singy, good to see you over there on the YouTube side as well. Okay, so one thing that I do want to talk about, because I know Psycode, you were interested in this last time we spoke. So let me actually just pull up a commit here. I did actually solve the picking issue, and it was actually a very slight tweak. I could probably actually just show you in the code. I was going to try and pull up the diff. I don't know if I checked it in separately though. I can't remember. I might have done. Yeah, here it is. Okay, so let me pull this down. So, the actual entire fix for the problem that I was having was this right here. I basically just needed to do a quick check to see if the point was inside the axis aligned bounding box after we already had done a intersects check. Right, so once we'd already done this check and it succeeded, and we also had confirmed that it's a leaf and not one of the nodes further up in the tree, which was also an important part of this, the next step was to essentially make sure that we checked to see if we are inside of the bounding box that we are checking, the leaf bounding box, right? And so the reason that we wait here to do that, till we get here to do this, is obviously we don't want to do this further up the chain as in the BVH, right? We have to wait until we get to this point and we actually confirm that we're inside of a leaf. The other thing that I did was I actually added a ignore if inside Boolean to the raycast function, because there are going to be situations where maybe we do want to include that in the selection. I'm thinking like physics. The physics system might eventually need this. So there's a Boolean here that I added to that to say whether or not to perform that check. And if so, go ahead and do it. But that's really all it was. Yep. I knew it was going to be something simple. It just took me banging my head against the desk for a little bit off stream to actually solve it. But yeah, it's relatively straightforward. Makes sense that the intersection test happens on every BVH level. We just want to ignore the ones on leaf. Yeah. So I initially actually had this check in this function, and it was like booting out way too early. And I was like, why is that happening? And then I was like, oh yeah, that's because we only want to do it on leaves. So we do allow this check to pass, and then it's sort of exclude it later on down here. So that was the solution to that. Most of the other things here are directly related to that, other than the fact that I added just the distance, the ray distance in here, and the position to it, to the callback. But that's kind of standard stuff when you're talking about hit results. So I went ahead and added those in there too. But yeah, there's nothing crazy going on here. In fact, I rolled back the negative infinity that we had in here, and I just reverted that to 0 and got rid of this check as well, that we'd kind of edited in there as an experiment. So literally the only thing we needed to do to fix it was just this. So I figured you would probably want to see that. So yeah. Okay. So with that, I basically did a series of other fixes. Most of them are not really important. I did also consolidate the geometry 3D functions into KMath, and I'm going to do the same with geometry 2D. I just want everything to sort of be under KMath, so I don't have all these separate includes everywhere. It got kind of annoying to deal with. So we're going to keep everything in one spot and just have all of our math stuff be in KMath. LSR, good to see you. Welcome. Apotham, you rewrote your NeoVim config on Sunday. Nice. Haven't done that in about 15 months. Went from something like 57 plugins down to 19. Yeah, I suspect I'm due to do that again. I actually do want to kind of slim mine down a little bit. I've done that a couple of times, but I still feel like I can make it a little bit more simple. But that's neither here nor there. If I do update my NeoVim config, I'll obviously update the article on the website and the global config file that I have. Okay, so let's talk about what we are going to get into on this episode. So one thing I want to just call out really quickly is we are on episode 298. That is the full episode in the actual playlist there. So we're getting really close to 300. So I'm actually kind of hoping that we complete some of this stuff before we hit 300, but we'll see how far into that we go. So the goal tonight is we're going to tackle, actually I added it in the title, so SSBOs or storage buffers, shader update frequencies, materials, and immediates. And so I've kind of written this out in my plan file. This is my .plan file that I've had since I think 2001. Yeah. So this is just kind of my work log that I've kept running all these years, but I've started actually kind of planning things out in this again. Essentially, I did a little bit of thinking about this offline about how I want this stuff to work. And the reason ultimately for all of these changes that are coming up and all this new stuff that we're going to add is to support the animation system that we are going to be adding. So that is the next thing that we're moving on to. We are going to be implementing animated meshes, or we're actually going to call them skinned meshes. And so we're going to be preparing for that. I've already done a little bit of scaffolding for that, so we'll kind of cover that maybe in detail when we get to that point. But I realized that there were some things that I need to do before we actually get to that point that we're going to need. So we absolutely need storage buffers for animations because that's where we're going to store all of the bone transforms. And we'll get into what bone transforms are and why we need to store them in an SSBO. But suffice it to say, there could be up to, say, 100 of these transforms per animated mesh that we have. And so that's quite a large amount of data to try and jam into a uniform buffer. Obviously, it far exceeds what makes sense to actually do there. And so we're going to need this feature anyways, and that really got me thinking about some other ways that we can improve our API and our shader handling in general. And so those are going to be some of the things that we're going to be tackling. So one big thing is I want to introduce the concept of what I'm going to call immediates to the renderer. And so what immediates are is they are essentially they directly translate to Vulkan push constants, right? Right now we call them kind of per draw. But there's some issues around that we'll kind of discuss. Essentially, what an immediate is it's a block of data that you can set immediately within the shader right before you make a draw call. And so I figured that should probably be its own sort of separate thing from updating your standard UBOs in the way that we do them now. And so I'm thinking it actually kind of makes sense, since we're separating this, to actually come up with some terminology for it and come up with a basic API of how we want that to work. And so because they translate essentially to push constants, Vulkan push constants, we are going to limit our immediates to a size of 128 bytes, which is the minimum guaranteed size that's guaranteed by the Vulkan spec. Now, we could choose to exceed that, right? But the idea of an immediate is that it's supposed to be a very small set of data to begin with. So I don't really believe that we should be actually exceeding that in any case. I don't think it really makes a lot of sense. We shouldn't be pushing a lot of data through immediates, right? So we're going to have some checks in place to actually verify that, right? Essentially, what immediates are going to be used for the most part, is indexing into large arrays of data, i.e., the storage buffer, right? Or we're sort of abbreviating that rather to SSBO. So essentially, what we're going to wind up with is we're going to have a function or an entry point into the renderer where we pass some data and a size of that data. And essentially, we're going to clip that data or essentially take a maximum of 128 bytes. So if you pass a structure that's larger than that and a size that's larger than that, essentially it's only going to take the first 128 bytes just as a sort of fail-safe. So again, this is not something that you want to be passing large amounts of data through. 128 bytes is not a lot of data. And we shouldn't really... I highly doubt we're ever going to actually use all 128 bytes. We might, but we'll see where we wind up on that. So there's that. And then it'll be set up in the shader config as like a immediate data size. So we'll have to verify that size is valid, i.e. less than 128 when we deserialize the shader config, right? So that's the first big concept. Is we're going to introduce that concept to the renderer. The other thing is we're going to be getting rid of, or replacing, I should say, the concept of per frame, per group, per draw. So this kind of worked, right? This was kind of another experiment or another direction that we tried to see how it would work, is to have these sort of predefined update frequencies, is the terminology we used under the hood, for sets of data, right? And so per frame was basically once for the entire frame. Per group was for a group of things, i.e. like a base material. And then per draw is pretty obvious. It's for every draw, right? So the direct replacement for per draw is the immediates here. And then per frame and per group, we're actually eliminating those as a concept entirely. And what we're going to do instead is we're going to have a more generic concept of index bindings, or I should say index binding sets. And we'll get to that in just a second. And this is going to be defined by the shader config itself, right? So we'll kind of get into that in just a second. And so the way that this is going to look is essentially we're going to have some different entry points for this. So we're going to have one where you set data, similar to how you do for immediate. You're going to set data. You're going to pass a binding set index, a binding index, an offset into that array if that's relevant, or an offset into that buffer if it's relevant, and then a pointer to the data itself and a size, right? So this will be useful for UBOs or SSBO data uploads, right? And then we'll also have one for textures and one for samplers where you pass a binding set, a binding index, an array index in the case of arrayed textures or samplers, and then, of course, the texture itself, right? So for non-arrayed textures or non-arrayed samplers, you just pass 0 here. And so with that, we will have this sort of shader config where we define these binding sets. And so binding sets essentially map, at least for Vulkan, they map directly to descriptor sets. So this is how we're going to manage that going forward. It's basically going to be a one-to-one mapping. So instead of having a mapping of, we always expect this per frame or per group or per draw, we are going to allow the shader to say how many mappings it has, and then it's up to the consumer of that shader or the thing that's populating that shader with its data to know how often that needs to be updated. And so that's going to take a lot of pressure off the renderer, off the shader system, and instead, put that on the consumer of that thing, right? And so generally your binding set is going to be just that, a set of bindings, right? So you'll have a name for it that's generally used for debugging purposes, with some sort of default. This is what will show up in RenderDoc when we're debugging. And then we'll have a use counter. So how many times these bindings are actually used. So for something that's in like a global context, that would typically be a single use. So it would just be 1, right? For something that is more of a like a material binding set, for example, so per material, that would be the total number of materials you want to have. So in our case, we have a max of 256 materials defined in our configuration right now. We're not going to set a hard limit on that. That's going to be configurable and passed into the shader renderer, or the material renderer, when we start that up, right? So that will be configurable and adjustable. And so the idea is that each of these binding sets will have bindings in it. And then the order that these appear are actually the binding index themselves, right? So here I've got an example that includes a UBO and also includes some storage buffers, right? So a UBO would essentially look like this, or a uniform buffer object. And so we'd have the type here of UBO. Obviously, it would also have a name, so it shows up in RenderDoc. And then we would have the data size, which is going to be the size of the uniform buffer object for that particular thing. Whereas the storage will work a little bit differently. So we'll talk about storage buffers here in a bit. But the idea here is, you define type of storage. You would give a name for it. And this name is used to either look up an existing storage buffer, if you're using one of the built-in ones with the engine, like Kohi Renderer Storage Transform, or for you to be able to provide a new one that has a name, and you can use that name across multiple shaders, right? So storage buffers are kind of global outside the context of a single shader. They sort of exist in a more global context, right? So in this case, we've got a storage buffer for transforms. We've got a storage buffer for lighting data. We've got a storage buffer for materials. Now, you could combine these things, but for now, we're going to leave them separate, and I'll get into to why that is in a bit. And then similar to sort of how our shaders currently work, we also have additional bindings for textures, right? So where we define the type of texture, obviously a name for it, the texture type, so this is a 2D, and then an array size of 4, that just means 4 2D textures, right? An array of those. Same with samplers, right? So this is how we would define our shadow cascade texture maps and samplers, as well as our IBL probe texture maps and samplers. So these guys are 2D textures and samplers. These guys are cubes, right? And then if we come down here, we've got, sort of another example of a binding set for materials. And the only thing that really has to exist here would be the textures and samplers per material, right? And so all of the actual material data in this example would actually exist in this storage buffer here. And so, this was a change that I was kind of on the fence about making for quite some time. But I think it's time, since we have to do this for animations anyways. We might as well switch over our material shaders to work this way, and perhaps some of our other shaders as well. Okay. So I hope that introduction makes sense as to what we're going to be doing and the purpose behind it. Let me catch up on chat. Let's see. I remember episode 1. It's nice to see it still running. Yeah, it's it's been quite the journey for us to get this far, for sure. MVP of the game by episode 300. I wish, right? Animation, haven't dived into learning that yet. Yeah, we're gonna be tackling animation. That's the next thing that we're gearing up for right now. Good old push constants, yes. Love them and hate them at the same time. Spiro, how's it going, buddy? Good to see you. Thank you for being here. No worries on being late, of course. So you'd use one of those binding sets for each passed node in the graph. So Spiro, you got 5 demerits from my wife. That's very funny. There's nothing about that I don't like. All right. So each one of these bindings is you can think of this as update frequency. That's the way these are split up, right? So the binding sets are update frequencies. So when I was saying we replace our per frame and our per group, essentially this is the per frame binding set, and this is the per group binding set that we have now. And the advantage of this is we don't have these sort of predefined scopes that exist. We can just configure them in the shader config, and then we can access them and use them as need be. And part of the reason that this is a really good thing is because we had several examples already of where some of these shaders did not have per group, or they did not have they didn't have per draw, even in some cases. The skybox, for example, didn't have anything per draw. And so this allows us to only set up the binding sets that we actually need for things. So it's going to be sort of a more flexible way to do it, where we can set a lot of this up in our configuration, and between this and the shader code get essentially 90% there. And then this is also going to make the updating of our uniform data or our storage buffer data a lot more efficient, because this is going to allow us to sort of do all of those updates at once instead of piecemealing them like we've been doing. So obviously we'll get into that when we cross that bridge. If they're edible demerits, I'll take them. That's funny. Low light over on the YouTube side. How's it going? Welcome. Okay. So I hope all of this makes sense. And so my plan for implementing this is basically I'm going to start at the Vulkan level and sort of work my way up, right? So that way I can determine that we have everything that we need at the Vulkan level, and then we can sort of just bring that up to the renderer front end and move on from there. Before we jump into that, though, I want to talk just for a second about storage buffers. So there's a couple changes that we needed to make to support storage buffers. And we haven't actually made all of them yet, but I've made a few of them, and I actually have it to the point where creating one works. We just can't actually use it yet because we don't have things hooked up. So previously, the render buffer type storage was not supported. That is no longer the case. So whenever we set up that buffer internally, we'll have a usage of storage buffer bit along with transfer destination bit. And then also our memory property flags are going to be host visible and host coherent, right? So we're basically going to be mapping a block of host visible memory to upload to, right? So we've got that. And then that was really, I think this was like the biggest actual back end change to add storage buffers, right? It was literally just adding this. The front end, we actually have a little bit more to do there, but I wanted to kind of leave some of it to do here on camera so that we can actually talk about this a little bit. So let's go to initialize. And when we're doing the setup of our buffers here, and note that I still have to make some of this stuff configurable. So what I've gone ahead and done here is I've created one of these, right? And we talked about, that we're going to have 3 of these. So I created one of them, and we're going to talk about how the others are going to be created. Now, obviously, we don't need something quite this large. This could probably just be, I don't know, it could probably be like 32 megabytes or something like that. Doesn't really need to be all that large. And we should probably also rename this to material storage buffer size, right? So let's take a look at the storage buffers that we're going to be creating, right? So I've already created this one for material data. Now this material data is this is the base material data that's going to be stored here. I did have a thought that maybe we could store some instance data here, some instance specific stuff, but I'm actually thinking the instance specific stuff probably will fit into our immediates. So I don't think we'll need to do that. So essentially for every material that we have, we'll be essentially uploading that material's data into a large array that will fit in this storage buffer. Right, and that's just called kohi.renderer.storage.materials. And so we'll have that. That will be a globally accessible buffer that's going to be queryable from the front end, right? So we probably will have to. I don't know that I actually named this. Yeah, I'll have to rename this to like what we have over here. Let me actually do that really quickly. So I'm going to take this and just rename this, right? And so, that's where all of our material data is going to live. So we're not going to have this per group thing that we're going to need anymore for, we're not going to have a per group UBO that we're going to need for this anymore. We're just going to store everything in a large array in a storage buffer that is purely meant for material data. The second one of these that we're going to have is a lighting one. So one of the things we did in a previous stream was we sort of set up a UBO. I think we did it on the global UBO to have this massive array for all the lights in the scene. That's rubbish, to be completely honest. And I didn't like it even then. I think I even said that on stream. So instead of doing that, we are going to have a separate storage buffer just for lighting data. And so that's predominantly going to be point lights for now. We still need to add spotlights at some point, and maybe some other light types. The only one we're not going to add to that is probably directional light, because there's only one of those per scene. But that is basically going to be the same thing. We're going to have a huge array of all of the lighting information. And then all we do is we pass indices of the lights that we want to use for that particular draw call in the immediates. And again, we can just index into that array out of that storage buffer, and we're golden. The next bit is we're going to also have a transform array. So we're going to take the transform out of the immediates, and instead we are going to upload all of the transforms to a storage buffer as well. This is going to include a bunch of mat4s, right? So all of our model matrices, essentially. But it's also going to include the positions for all of that stuff, right? So all of the positions. I guess we could try to decompose the matrix and like pull it out of there, but I don't think that's going to be the way to do it in terms of speed, right? We don't want to have to do that for every vertex. So this is going to contain whatever transform information we need to actually have on the GPU. We'll kind of evaluate that as we go. Another thing is we are going to have this, and I haven't really decided. I think I might put this in the transform one. I haven't 100% decided, but we also need a place to put all of the view matrices, and maybe even the projection matrices. We need to put an array of those somewhere, because right now we have it kind of hard-coded in the UBO, and I don't really necessarily think that data should be living there, right? And so this binding here, this global UBO, the data size 2048, this is really here just as an example. I'd like to actually not have a global UBO at all. I'd like to be able to get everything that we need globally to render a scene out of one of these storage buffers, right? So that's kind of the goal there. I might rename this one to something other than just transforms, but for right now, that's kind of what I came up with. Let's see. Off topic, perhaps, but how are you starting game dev? What was your first project or something like that? Well, first of all, welcome, first-time chatter. Welcome. Welcome to the stream. I appreciate you being here. So if you're asking how I got started in game dev, oh, good Lord. That's going back a really long time. I mean, I did a bunch of contract work before, over the years. Before that, I did kind of some projects on my own. After that, I did work for a game company for about 5 years writing game engines and games. How I got started, though, technically starts when I was like 7, technically speaking. Because I started programming because I wanted to make games on my own. And I learned Microsoft QBasic on a MS-DOS 5 machine. And those were technically the first games I wrote. So yeah, it's a bit of a loaded question. I suppose I probably ought to maybe I ought to make a video on that. That's a little bit more organized, at some point, but yeah, I've been doing it a long time. In fact, this plan file here that I have, kind of documents all the stuff I've been doing. I've been thinking about releasing this publicly. I have to kind of scrub it to make sure that, there's nothing in here that I don't necessarily want going public, but, I've kept my development logs all the way back to 2001. So yeah, and that was like back when I signed up for Garage Games and really got into, developing games with an engine. Ordered the book you recommended. It's been amazing. Are you talking about the game engine architecture book? Yes, that is a great book, especially for learning the basics of an engine, right? It's pretty high level, but there's lots of good stuff in there. Yeah. All right. Awesome. Baguette, it's good to see you. How are you doing? Hope you're doing well. All right. So one of the things that that we want to do in here, and part of making this configurable, I think, really is going to wind up being based on the size of what we put in these buffers. So I think it's going to be how many things we actually want to represent. But for now, I'm not going to do that. I'm just going to, I'm going to kind of go through here and just kind of create them for now, and we can always tweak them later. So we have global, this should be global material storage buffer. And Let me just bat this over to the side for a second. So the only difference is when we're creating this one, we have vertex and index up here, or uniform from inside a shader. We use the new render buffer type storage in here, and we are using a free list to track this. I don't know that we necessarily need to do this either, because I have a feeling that we're going to wind up using just the entire buffer. I don't think we're going to be doing a whole lot of freeing of data, right? So I'm thinking we're probably going to wind up getting rid of that. In fact, I'm going to put a fix me in here. Change to not use allocation tracking. Okay. So that's the idea for that. So we have a global material storage buffer. The other thing is we need to create one for transforms and one for lighting. So we need to actually get the names for those in here. So one is going to be transform, and one is going to be lighting. And we're actually going to do transforms and lighting. Actually, let's just make it transform, right? So let's go over to the states, and we're going to actually put in 2 more of these things. And I guess we can call this global. I guess we could say global transform and global lighting storage buffer. I guess we'll kind of go with that for now. We might wind up renaming it to something that makes a little bit more sense in the future, but yeah, let's roll with that for right now. So we'll take this, and I'm just going to copy this block here. And so this is going to be, I guess we'll go in sort of reverse order here. So lighting, I guess, will be next. So we'll do 8S lighting, and lighting here, lighting here. This needs to be global lighting. This should be material, and then this should be lighting, right? And I'll leave that at 32 megabytes as well. Again, we're going to be figuring out the size of those things once we actually figure out what data we need to store there. And then this is going to be lighting storage buffer, right? So we'll take this and we'll copy pasta it one more time. And we'll do transforms. Transform storage buffer. So again, that's going to be, oops. Transform storage buffer, transform, whoops, there we go. And then obviously the name. Also, did I actually change, I don't think I changed this. Yeah, this needs to be, that needs to be lighting. This needs to be transform. Okay. All right, cool. So those are the 3 storage buffers we're going to create. We are going to follow this this sort of plan here of having all of these things on a single binding set. That way we're not exhausting our descriptor sets, right? Because we do have hardware out there that does have a limit of 4 descriptor sets being bound at once. And so we want to not go over that in any way, shape, or form. So what this is actually going to do is we're actually reducing a descriptor set by going with this. So this is going to translate into one descriptor set for all of this stuff, all the way down here, and one more for this. And then, the immediates are push constants, so we don't actually need a descriptor set for that. Let's see. My dyslexia is kind of hitting me hard. Is that a I or an L? Is it Ichani or Ichanchi, or is it Luchanchi? First time chatter. I butcher names all the time, so welcome. But yeah, welcome to the stream. Glad to have you here. How are you doing tonight? It is an I. Okay. It always drives me nuts because the like iPhone. Okay. There's so many fonts out there where a lowercase L looks exactly the same as a capital I, and that absolutely drives me batty. Can't stand it. Nicolite over there on the YouTube side, how are you doing? Welcome. Okay. So these are the 3 buffers we're going to use. I don't think we're going to need more than this. I think the transform buffer is actually going to contain a little bit of other data that we're going to need. But that's because the other data that we're going to need, I don't think warrants the creation of another storage buffer, right? I don't want to go crazy with creating too many. In fact, I'd actually like to combine these into one storage buffer eventually, but that's a little bit more complicated. I just want to kind of get it to work first, right? So I think, let me actually build. I think we should be able to actually run if I haven't broken anything. So let me actually just make sure that those get stood up correctly. They should. And in fact, I'm just going to bat this off to the side and take a look at the logs. So let's see. Here we go. Created global storage, global material storage buffer, lighting storage buffer, transform. And here's the addresses that those were created at. So they did create successfully, so that's good. Oh, I keep forgetting about this bug too. You know what? I should probably fix that. So this is a bug where if I click on the window, it's actually trying to raycast into a scene that isn't loaded, which is kind of dumb. And I keep meaning to fix it, and I keep forgetting it. So maybe I should just fix that real quick. Let's go to game on button. And here's the scene states. Oh, wait a minute. If the scene is loaded. Wait, why did that actually... Oh, right. Because we don't have a current zone, do we? We do not. That is really the bug. Okay. So I guess we're going to have to go one more layer of this, which I don't really like nesting it this far, but here we are. So we'll say if state zone state current zone. Then we'll go ahead and do that. Just rebuild that. It's a minor bug, but it's kind of an annoying one. So now, yeah, now we can click and it doesn't crash. Perfect. We're not destroying some stuff though, so we'll have to look at that. Oh, we're not, you know what? Yeah, I know what that is actually. So in our renderer, we just created those new buffers, but we're not actually destroying them. So in the shutdown, we're actually destroying one of them, but not all of them. So let's go ahead and fix that. So global lighting storage buffer and global transform storage buffer. Just make sure that that is doing the thing. All right, so we'll shut down, and there we go. Okay, so we want to try and avoid obviously creating problems where there aren't any. Okay, so as far as the renderer is concerned, I think that is all we're gonna have to do for now, for the front end. There is, however, one other thing I forgot to talk about. All of this stuff, one thing that you don't see in the shading config here, or the shader config, is we don't see uniforms anymore. And that's because we were kind of trying to emulate the way that OpenGL sort of handled uniforms in its API. And that was successful. We used that for a long time. It worked well. It made it really easy to configure these things. But the further I got along into it, the more I realized, it really just makes sense to just kind of pack everything into a struct and throw it over to the shader all in one shot. And that's especially true now that we're dealing with storage buffers. So the concept of individual uniforms is going away. We're not going to be doing that anymore. Therefore, all of the logic in the shader system and in the Vulkan backend that deals with uniforms is going to go bye-bye. We don't need that. We are simply going to deal with uniform buffer objects, which are simply structs. We're going to deal with that going forward, and that's going to be it, right? We're going to deal with large chunks of memory just being moved across from host memory to device memory, and that's going to be that. Let's see. Recently, back in school, and I've been looking into working in the game industry. Awesome. Well, good luck on that. Yeah, best wishes on that for sure. The game industry is an awesome place to be. It's not all candy and cake, but, to each their own. Been there and done that, got a dresser full of t-shirts. But I digress. Okay, so I guess the next step would be, I feel like the simplest thing to put in place first is probably going to be the concept of immediates. So I guess let's go ahead, or I guess actually maybe we should probably bang out some of our shader configuration, right? So we know what that looks like. This is actually kind of what the material one's going to look like, which is kind of what I was modeling this whole thing after, because that's the most complicated example that we have. So I guess we could do that, but I feel like immediates is probably a good place to start. So let's actually go to the Vulkan backend. And we're actually going to be able to get rid of a lot of stuff out of here, which is great. Let's see. I guess I want to search for push constants, right? Okay. So whenever we're creating the graphics pipeline, we want to create push constant ranges. Push constant range is always going to be 0 to 128, pretty much. So I'm not really thinking we have to change that. What's really going to change is this section. So we have this Vulkan renderer shader apply draw. This is essentially going to get replaced with the set immediate data. So I guess let's put this, right in front of it. And incidentally, I'm thinking immediate data is only probably going to apply for data. I don't think we're going to support per draw textures. I think we probably ought to just have a separate descriptor group for that and call it a day. I don't necessarily know that that's the right call now, but we'll adjust it if we need to. Let's see. The other thing is, a lot of our API functions return Boolean for success or I should say a Boolean, true for success, false for a failure. Thank you for the follow, by the way. Appreciate that. I think we ought to maintain that here. So we're going to say Vulkan renderer, and we'll do, I guess we'll do shader set immediate data. And we're essentially going to follow kind of, what we had determined was going to be the path in our plan over here. So renderer backend interface is what we're going to want for that one. And then obviously we're going to want, we're going to want the shader, I think. Renderer frame number, I don't think we actually need for this anymore, so I'm going to omit it. And we're going to do a void pointer data. And then we'll do a U60. Wait, I think I said that was going to be a U8 for this one because it's limited. Yeah, U8 size because it's limited to 128 bytes. We don't really need anything larger than that. Now, what we're going to do is we're going to rely on the front end to have already trimmed this data, right? So it's either going to take the size or 128, whichever is smaller, and go from there. So the other thing that we're going to rely on is that the front end is going to be smart enough to say, hey, if we pass a zero size or zero data or invalid shader or any of that kind of crap, we're going to filter all that out on the front end and not make the back end responsible for that. So we are going to need the context, the RHI. I think we're going to need the internal shader as well. So we'll go ahead and grab those things. That's not changing. I don't think we're going to need bound ID. I don't think we're going to have to do any of that stuff anymore. We don't really need to allocate resources for that. So we can actually get rid of that as a concept as well, at least for immediates. Let's see. We are actually going to need... the command buffer. So we'll go ahead and put that in. Let's see. Command push constants does require the pipeline layout. Does require that. Okay, so that's why we need the correct pipeline. So actually, we can actually just grab this entire bit of code here. So this is also going to be the same. Depending on whether or not we have wireframe enabled, we'll pick the right pipeline to push to. And then we will update, update the non-sample uniforms. Okay, so we're just going to say update the data via push constant. Oops. Okay. We can see here that that's already hard-coded to go from 0 to 128. We're going to keep that. Actually, wait a minute. Let me look that up in the spec. Let's see. So offset is 0. Yep, we want to keep that. And size. Size is the push constant. Okay. So there is a bit of logic here we have to think about. So whenever we are talking about the push constant range that we set up whenever we set up the graphics pipeline for the shader, we just hard code that to be 128 bytes, which is fine. But we might not always use 128 bytes, right? And that's kind of what this is doing here. And so this is actually going to require 128 bytes. Now, I could change this number, right, to not be 128 bytes. And I could change it in the pipeline config to not be 128 bytes. But I think it's far safer to just say, let's take a 128 byte block of memory and just use that instead, right? So what we're going to do is we can actually do that on the stack, right? So we could just do a U8 array. Should be good enough. And we're going to do, I guess we'll call this block, right? And that's going to be a block of 128, right? And we're just going to zero that out. And then we'll do a k copy memory. The destination is going to be block. The source is going to be data. And the size is passed in. So the advantage here is that we always have a 128 block of memory, no matter what we do. We don't have to worry about, if this isn't actually passed in 128 bytes of data, we don't have to worry about, the potential disaster that could happen if we bleed into other memory down, after that, right? So this just kind of simplifies that process for us. And then instead of using the internal shader per draw push constant block, we're just going to use the block. Oops, there we go. So that just kind of simplifies the whole thing. Now, as far as this goes, there's not technically anything that can cause this to fail, but that may not be true on other renderer backends, right? So we want the interface to still return false if we have some sort of failure somewhere, but this particular command here, is return type void. So there's not really anything that we can do about that. We just have to. We're just going to return. Return true. True. There we go. If I can type. Oh my goodness! I keep hitting the wrong keys.
You dingus.
Yeah, dingus is correct. Let's see. Doesn't UBOs have a 256 byte limitation? Or is just their alignment that is... So, how's it going, Tammin, by the way? Good to see you. So what you're thinking of is the alignment requirement of UBOs, specifically for NVIDIA GPUs. So that is something that we do query in the when we set up the Vulkan device, we query that. So we do actually have that. So when we set up the actual UBO, we will have already done the query and we'll use that appropriately. But that doesn't really apply to push constants, right? This is a separate deal. Not sure if I mentioned this, but thanks for making Kohi. I thought it was crazy. Trying to make a game engine in C, nice to see someone else doing it too. Rather, seeing someone else make a C engine motivates me to keep it going. Well, that's awesome. I appreciate the kind words, by the way, and I'm glad to provide motivation, right? That's kind of actually the point of me doing this, is to say, yes, you can do this. It's not completely crazy, and it's not that hard either. Here's how we do it, right? LaFoley, good to see you. How's it going, bud? Smallest guaranteed UBO is 64K, if I recall correctly. Alignment is 256, but I think it's device dependent. Yes, it is device dependent. Because I've got an AMD card here that says otherwise. Yeah, so the 256 limit is, or requirement, I should say, is mostly an NVIDIA thing. But we do take that into, ATI, exactly. Aging myself there, right? Let's see, what was the other thing I was about to say? Smallest guaranteed UBO is, I think Vulkan actually says, I think the smallest guaranteed is 16K. I could be wrong about that, though. Most devices do have 64K, but I want to say it was 16K. But like I said, I could be wrong about that. I'm good, LaFoley. How about you? Need some motivation to solve this rare ALSA underrun loop that seems to only happen on my machine. Oh, geez. Oof. Let's just put it this way. There's a reason I went with OpenAL instead of doing that manually. But I will say, who was I talking to that was actually doing that? Was it Magetz? I think it was Magetzub that was actually working on that. Or it might have been Pipewire, I can't remember. But I think he was doing that from scratch, if I remember correctly. Working on the map generator for the mod. Nice. That's awesome. If I want to start programming, is my 2022 MacBook okay to use? More than definitely, yes. In fact, I have a 2021 MacBook Pro that I use. That's actually what we're streaming from right now. I should say, it's what's running OBS that's capturing this screen. But I also program it on it all the time. It's awesome. Yeah, it's definitely just fine to use. Yeah, that'll definitely be plenty to do it on, for sure. I think for Direct3D 12 is 64K as well. Yeah, it might be. It might have been. I can't remember. I might be confusing it with something else, but I could have swore it was 16K. I can't remember what the actual thing is to look it up, but I don't usually use UBOs anymore. Moved everything to SSBOs since I don't need to support mobile. Which is when you kind of want UBOs. Yeah, so I've already determined that if I do mobile support on this engine, it's going to require like a different Vulkan pipeline to begin with. So I'm just going to implement that separately if I ever go that way. It was you, Magetz. I thought so. Yeah, you've done both ALSA and Pipewire. So yeah, you guys may want to talk. Yeah, LaFoley's working on a mud with Spiro, actually. Personally would opt for a Windows Linux machine for games. Yeah, I mean, it depends, right? If I want to learn how to make video games and use engines, which is the better option? Yeah, that's a it depends answer, right? Like a lot of the bigger game engines support Mac OS these days, so that's perfectly fine. I always say use what you have, right? If you have both, try it on both and see which one you like better, to be completely honest. I personally like working on Unix-like systems, right? So that includes Mac OS and Linux for me. I usually lean more towards Linux, but I also much prefer developing on Mac over Windows, for sure. Read as my question was read, I got ads. Oof. Let's see, which question was that? Because I can re-answer it for you if you want. Decided to go for a larger world using ProcGen to generate the static data. Thus, I'm writing a GUI tool that we can visualize the output in real time. That's awesome. Can post a shot if links are enabled. LaFolia, I think you give it a shot. If not, then you know what? I don't know why you aren't. Hold on a second. LaFolia, I don't know why you're not a mod. I've made you a mod. So now you should definitely be able to do it. I was looking into building a micro ATX Linux machine as my first Linux build. That's awesome. Don't miss my rant about ALSA. Let's see. On ALSA, I do the memory mapping instead of submitting buffers. It scrolled. I'd rather have the sound card tell me how many samples is available than try to estimate a buffer size. Yeah. I would agree with you on that for sure. All right. T-Met, how's it going? First time chatter, welcome. Okay. So where were we? All right, so I literally think this is like everything that's going to be required for set immediate, right? So there's that. Pretty straightforward stuff, I think. So I am actually going to come down here, and I actually want to remove this push constant block from the shader. So I'm going to do that, because we no longer need that. And then I'm also going to, let's see, apply per draw. Let me actually get the per draw info out of here as well, because that doesn't exist. Per draw states, that does not exist anymore either. So kind of as I go through here and remove these things, I want to go through here and take the data out of the shader states as it makes sense to do so. Okay. So, and that just introduced a crap load of errors, which I'm not surprised. Okay. So our set immediate data is now how we are going to essentially set our push constants, right? So I guess I can take this over to the header file, and I'll just put this right here, and I'll get rid of the apply per draw. That way anything trying to call that bleats about it. Also, the per draw and resources acquire and release, those we can actually get rid of as well. We don't want those anymore. All right, and also the bind per group and per draw, or actually just per draw, the binding for that, we also do not need. So we can actually remove that as well. Okay. So let's see. We don't need, whoops. We don't need, wait, what did I delete out of here then? Per draw. I think I might have actually deleted the wrong thing, but we're going to be deleting all of this stuff anyways, so I'm not actually that worried about it. Also, all of this uniform stuff is all going to be going away. So actually, this uniform set stuff, that's going to be going away. So we can actually get rid of that as well. Per group resources acquire, that is going to be going away. I guess I could go ahead and delete that now. The acquire and release for that. We don't need that anymore. Okay. Let's see what some of the errors are. Okay, so we have shader frequency stuff here. Setup frequency states. Okay, so this no longer exists. So we can delete that. We'll obviously have to come back and delete this function later on, but there is some stuff I want to actually retain out of this, so I don't want to nuke the entire function just yet. Okay, so release frequency state, that's going to be the same thing, same deal. Create modules and pipelines. Okay, so we do not actually have always one block for push constant unless there are no per draw UBO uniforms. Okay, so push constant range, we're always going to have one of those. Well, wait a minute though. This is where this is where we actually, when we're setting up the push constant ranges for the pipeline config, we actually need to know what that size should be. Or we just set it to 128 and forget about it. Although we're not necessarily going to use that for every shader. I guess... How should we handle that when we're actually creating the shader module? I guess we could... I don't really want to allow or require the push constant range or the immediate size range to have to be set in the shader config. Although I guess it kind of makes sense that maybe it should be. So let's maybe look at... Let's look at the internal shader. And I guess what we can do... Maybe we'll put it up here. We'll do a U8 immediate size. Right, and so this will just be the size of the immediate's object block of memory, I guess. It's kind of a crappy explanation, but it'll work for now. So we'll do immediate size here, and then we'll do same thing here. So we'll do that. So if we have immediate size defined, then we'll use it. Otherwise, we won't. I guess that makes sense. Okay. All right. So set up the internal shader. Here is where we were pre-allocating a push constant block. We don't need that anymore. We also don't need the per draw info. We don't need the bound ID. That stuff can all go. And then, of course, again, info here does not need to exist. Same to go with sorted indices. Let's see, what was this? This is having to do with sampler and texture uniform indices. Okay, we don't need those anymore. So that can go as well. UBO stride. I don't know that we actually need that for this. So I'm actually going to delete that. And then has per draw goes away. Per draw sampler counts. Per draw. Right, that's not taken into account. Image counts, we don't need that anymore. We don't need this. We don't need this or this. Has per draw, descriptor set config. So we don't need this either, because we're not going to allow descriptors at that level anymore. Per draw state invalidation, we don't need any of that. Same here when we go talk about the UBO stride. Here's the per draw states, don't need those. And again, Here's even more destruction stuff we don't need. Okay. So that actually builds. Well, it's not going to build, but the errors have been eliminated. Okay, so that handles immediates. The next thing that we're going to have to do is talk a little bit about uniforms and the removal of uniforms, right? Because we're not going to do that anymore. We're just going to be dealing with UBOs or storage. So we have this concept of frequency state, right? This Vulkan shader frequency state. So this is for like descriptor set updates per frequency state, right? Instead of having a frequency state, what we're really going to wind up having, bring this over here. What we're really going to have is a set per, let's see. We're going to have essentially one of these states per usage of a binding set, right? This contains things like the descriptor states for the UBO. We'll also need one probably for the storage buffer as well, but then also the sampler state and the texture state. The descriptor sets as well, right? Let's see. Offset and bytes in the frequency uniform buffer. So again, that's probably going to be another thing that we're going to have to keep in mind. So I think I'm debating whether to reuse this texture or just rewrite it from scratch. Let me see. Catch up on some chat here. Audio memory mapping is greater than or better than buffer submitting. I can see where that makes sense. Let me click this link. So let's see. What was this again? Oh, this was for the... This was for the procedural generation of... That's pretty cool. Yeah, that's pretty neat. I like that. Let's see. Does anyone have resource recommendations for a beginner in programming for self-learning? Heard Python is a good starter language. I don't know if that's recommended or Java. Depends on what you're doing, right? If you're wanting to go game programming, probably neither of those. LaFollie's recommendation of Lua and C are probably pretty good, right? Lua is used a lot in a lot of places. I would say I do agree that while C is much harder, I also agree with him that it will take you much further. So here's the thing. C definitely has a much steeper learning curve, right? But what you get with that is once you have a solid understanding of C, learning just about any other programming language will be much simpler because of that. So my recommendation for a lot of people is usually to start off with C, not C++, right? That's a much more complex language. You can move to that after you learn C. LaFollie is also recommending Odin. I can't speak for or against that. I haven't used it. Stay away from OOP languages as long as you can. Yeah, so again, stay away from C++ right away, right? Start with C, get good with it, and that will take some time, right? But I guarantee you, if you get good with C, and you start with that, any other language you choose to learn will be much simpler. Skyuba has a good point, though, unless you want a job in today's market. Yeah, I mean, if you're going to do web dev or something like that, then obviously that answer varies greatly. Although I still say learn C at some point, but obviously, for web dev, there's a variety of languages you'd have to learn. So it depends on what you're wanting to do. But yeah, if you're talking blank slate from, if you have the time to learn, and it's not to like try and place you in a job in 6 months or a year, then yeah, start 100%. Start on C. I would love Odin. I just don't know it yet. Yeah, I mean that's the thing. You know, I want to try it, but like it's one of those things that I've got a 70 plus K lines of code base. I don't really want to move to that. Sergeant Pepper rating with a party of 11. Thank you so much, sir. What did you get up to on stream? Thank you so much for the raid. Good to see you. How have you been? For those of you who aren't following Sergeant Pepper, definitely go do it. He streams a lot here on Twitch. What are you working on at the moment, actually? Dustin, my dude, it's good to see you as well. It's been a bit. How are you doing? Started the Kohi series again. All right, that's awesome. I appreciate it. Was just upgrading the 2E framework for one of my apps so I can fix some bugs in it. Want to get back to my Godot game tomorrow, though. Okay, that's awesome. Yeah. Sweet. I never seem to be able to catch you like when you're streaming, because you're always either streaming when I'm streaming or like when I'm not able to actually watch a stream. Just seems to be timing, you know. Terminal UI though, yeah, that's awesome. That's very cool stuff. I'll have to check that out. I'll have to look at the VOD for that. Very cool stuff. Well, thank you so much for the raid. Welcome, raiders. For those of you who aren't familiar with what we're doing here, I'll just kind of give the 2 to 3 minute recap. We are building something called the Kohi game engine, which is a game engine built completely from scratch in C using Vulkan as its initial rendering backend. I say initial rendering backend because we do have support for Direct 3D and Metal planned for the future. It is cross-platform compatible, available on Windows, Linux, and Mac OS, with other platforms such as consoles and things like that planned for the future. It is completely free and open source. So it is available here on GitHub. In fact, I'm going to drop a link to the main website that you see here, KohiEngine.com. That's sort of the main portal to all this. Down here, you'll see a link to GitHub. If you click into that, you'll see that it is free and open source. It is Apache 2.0 license, which means that you can use it for whatever you wish, whether it is personal or commercial. Does not matter. All that I ask is that you say you use it if you do. The engine itself is an educational resource. So we are looking at this. I started this series as an educational resource that I kind of wish that I had when I was learning how to do this stuff. It's a way to build a game engine. It's not necessarily the only way to build a game engine. Sometimes not even the right way. Sometimes we do a lot of experimentation and trying things out on this channel. Some things work, some things don't. We do a deep dive into those things either way. And so because this is an educational resource, I believe that should be free, and thus the game engine will always be free in perpetuity. It will never have any sort of licensing fees or royalties of any kind ever. It will always be open source and free. The games that I make with it, the game that we're currently making with it, will not be open source, at least immediately. It probably will be open sourced sometime after release. But yeah, there you have it. That's the quick and dirty sort of overview. Just a couple more things. We do simulcast to YouTube and Twitch. I stream twice a week. We do have a Discord server with about 1,000 people on it. And then, of course, the GitHub link is here. And there's a Patreon link. I don't have any sort of supporters. I have supporters. I don't have any sort of sponsors of any kind, just you guys. So, I'm not driven by any of that kind of stuff. So, yeah. I hope that pretty much answers any questions you guys might have. So what we are currently in the middle of doing is we are changing up things in our rendering a little bit in terms of how we handle shaders, and we are changing up how we actually handle descriptors, descriptor sets and descriptors. within those shaders, and streamlining rather our API quite a bit to make things leaner and meaner, as well as adding storage buffers, which is kind of what's allowing us to do that, right? So we're moving away from sort of the traditional OpenGL style updating of uniforms everywhere and sticking with uniform buffer objects and or storage buffers for that stuff instead. And so we're getting rid of a lot of the overhead and making things lean and mean as far as that goes. Thank you for the lurk. Going to get some dinner for a bit. Appreciate that. Yeah, go get your dinner. Do what you got to do. I appreciate the raid. Thank you so much for the raid. I really appreciate it. Busy. Life got in the way of my goal following your series using Zig. But the summer craze has calmed down, so I'm trying to get back to it. Awesome. Well, welcome back. Glad to have you back. And yeah, I would be interested in seeing, how that Zig port goes eventually. But I'm also interested, if you take it your own direction, I'm interested to see how you do that. Because the whole goal of this is to not necessarily follow it exactly, but to sort of take the bits of this that are useful to you and use that to build something, right? Or eventually, once the engine is mature enough to be able to take this and build something with it directly. Anyway, so the idea is that we are switching away from this sort of per frame, per group, per draw binding system that we had before to binding sets, and that's kind of what we're in the middle of now, and we're sort of defining how that should work. So we've already actually knocked out this first bit. I'm actually going to plus this because we've actually done those things. And then we do need to actually read in the shader config, so that's going to be, I'm going to leave this last one untouched there. Let's see. So, binding sets. So, before we had this sort of frequency state, which there was a frequency state for per frame rather, per group and per draw. We're not going to have that anymore. We are going to have what I'm going to call binding set state, right? And this is for the, we're going to say the state for a shader's binding set, right? And we're going to do away with the rest of that line. So the binding set, we're going to have a couple things. So for the global binding set, we only have a single use of this, right? So we'll have one of these, right? But it's up to the shader to kind of configure that. So just because, we have a shader that looks like this, a shader config that looks like this, that says, it has one here. That might not always be the case for every single shader, right? So we do want to have the ability to have more than one of those. So this is essentially the state that is used for each one of those individual uses, right? So I guess we should say binding set. Do we say binding set use state, maybe? Maybe that makes more sense, right? So we could say the state for a shader's binding set, let's see, for a shader's binding set individual usage, I guess. I feel like that's worded awkwardly, but essentially for each one of these binding sets, and then per max use count, you'll have one of these, right? So there'd be one of these for this set. There'd be 256 of these for this set, right? So the offset and bytes in the frequency uniform buffer. Okay, so we don't really have that anymore. However, the UBO, we should probably think about this for a second, because actually this brings up something that I left out of this sort of design, which would be the offset, which we would need to know. So I guess we do need an offset in here, right? So that's going to be into the uniform buffer. So obviously there'd be one uniform buffer for the entire shader, right? That's what we have there. And for each usage into that, we need a data size and an offset. 2048 is kind of ridiculous, by the way. I'm going to shrink that down some. So I guess that makes sense. ID, this was sort of for the binding of it. I don't know if we need that. I don't know if we need that. I tend to think not. But I'm thinking we also use that for, this invalid ID if not used. I'm thinking we use that to determine what slots within that usage array, or the new usage array, is going to be free. I am actually thinking, instead of that, let's have the offset be invalid ID U64 if unused. Now, what that means is, if we have 0 here, 0 is actually a valid offset into the array, right? More than likely, though, invalid ID U64, which is max uint 64, is not going to be valid. So we can actually use this as the switch to say, hey, this one's available or it's not. Here are the descriptor sets for that particular frequency, one per color image. I think that's probably fine. UBO descriptor states, that is for, we could potentially have more than one UBO binding, although I think that's kind of stupid. Should we allow more than one of these? I don't think we should have more than one uniform buffer object. I think we should just say there's one and that's it. One per binding set, rather. So I guess we could just say one UBO descriptor set for this, descriptor state rather, for this set. Max of one UBO per set. And then we have sampler states and texture states. So these we do want to keep, right? Because those are for individual bindings like this, like the texture or the sampler that we have here. We want to keep those. Let's see. We have shader update frequency. That I'm actually it's gonna cause a bunch of errors, but I want to delete that out of here because that'll tell me everywhere that that's being used. So let's get rid of that. And instead of that, we're gonna say we have descriptor set index. I guess I'll keep that now for debug purposes. I'm going to say, well, actually, descriptor set index is actually going to also be the binding set index. So also the binding set index. Okay. So I guess that makes sense. Okay. Let's see, we have the Okay, the other thing we have is the sampler state and the texture state. I think we can keep those. The Vulkan descriptor states just has the render frame number per essentially swap chain image. Configuration for a descriptor set. Okay, I think we can keep all of that. Let's see. Vulkan shader descriptor set layout 3. Okay, so this is one of those hard-coded assumptions that we were making before that we do not want to keep, right? We do not want to make that assumption. So anywhere that assumption is being made, we need to fix that because we're not going to now have always 3 of these, right? We had it before where we had per frame, per group, per draw. But now, we can have as many as 4. Or as few as technically 0, essentially. Technically, you could have a shader that doesn't have any of them, right? Or maybe just one. Let me see. Got some comments here, I think. Let's see. Love the learning aspect of your series and how upfront you are about every aspect. Much respect. I appreciate that. What's a binding set? Is that kind of like a batch? It's basically a direct mapping to descriptor sets in Vulkan. Refers to different data groups you're sending to the shader. Set doesn't have a fixed meaning. So that's the thing, right? So Psycode pretty much nailed it on the head. We had this concept of splitting up descriptor sets by update frequency, right? So we had this concept of per frame as a frequency, per group as a frequency, per draw as a frequency, right? So these are all have different frequencies of updates within the course of a frame, right? So a per frame update frequency would happen once per frame. Per group would happen towards, once per group of things. So if you're rendering materials, right? However many things you have using that material would fall under per group, right? So that'd be your material properties for, say, a wood material versus a metal material, right? So each material that you would have a per group, right? And then per draw is each instance of the thing that you're drawing. So for every draw call, it's that draws specific data that we need at that level, right? And the issue with this is that not everything that we do falls into these 3 categories neatly. We have some things that don't use some of them or most of them, and some things that use all of them, right? So, for example, a skybox has per frame data, right? So that's we only need to set the cube map texture for that once. But it didn't have any per group, and it didn't have any per draw. Uniforms that needed to be set, right? And so rather than going through all the overhead and having to set that stuff up every single time, we just allow the shader to say what it has. And then whatever is consuming that shader will know when to update that binding set, right? So a binding set is essentially a replacement for each one of these things. So you can think of this as a binding set, this is a binding set, and this is a binding set. And then within that, we have the individual bindings, right? So we have a binding, these are indexed in order, right? So we have the first binding in this example would be the uniform buffer object, which would contain a whole block of memory that has a bunch of uniform data in it that we want to pass to the shader. And then we have another binding here, which binds to a storage buffer, and then another storage buffer and another storage buffer, but all within the same set, right? So the reason I chose this example is this is like how we would render materials, for example. So we have these sort of sets of global scene data, if you will, that everything in the scene is going to have to know about, regardless of what type of material it is or whatnot, right? You're always going to need the scene transforms, the lights within the scene, and all of the material data within the scene, right? And then your immediates, which are sort of taking the place of the per draw here, you would use to index into these arrays of data, essentially. And so that's kind of the mapping there. I hope that makes sense. Apotham, you're thinking of putting your game engine you're working on the shelf and restart it? 3 years of starting and stopping has just resulted in everything being so different. I'm not even sure how most of it works anymore. I've been there. I've been there and done that many times. Sometimes it's better. I mean, it depends on how far you are in it and how much you have to rewrite, right? There's always the sunk cost fallacy as well that you have to consider. So you have to just weigh that out about like how much effort is that to rewrite it from scratch versus refactor what you've got. How much time have you sunk into it? Is it worth doing it in either way? Howdy doody, first time chat. Have you thought of using bindless? I have thought about it, but not all hardware out there supports it. Not all desktop hardware out there supports it in Vulkan, unfortunately. And what I don't want to have to do is write 2 rendering paths to support it where it's, to use the new stuff where it's supported and use the old stuff where it's not. And so I'm just doing it the old school way because I don't want to have to write 2 paths of code. Because I'm also going to have to support multiple backends with this, right? So this is the Vulkan backend, but we're also going to have one for Metal, so we can run that natively on Mac OS. And I also plan on having a Direct 3D backend, so that hopefully we can eventually port to Xbox. Sad path we've all walked. Don't lose faith. Yeah, I agree with Dustin on that one. It's much easier the second time around. What do you mean, Skyub? Dingus Dev, good to see you. Should really pay closer attention to these systems as you're designing them, working on a much, much smaller 2D system for reading and config rule sets at runtime to draw my widgets on the screen, but it's kicking my ass when I start adding uniforms, shaders, etc. Yeah, figuring this stuff out. I mean, I'll be totally open and honest here, as I do on this stream a lot, right? Bindings, like, and descriptor set management has been one of those things I've changed it a few times, just trying to figure out what works the best, right? Because coming up with something that is generic enough to be able to be flexible to do different things with it is hard. It's very hard. This is one of the hardest aspects of Vulkan, I would actually say, is actually managing descriptor sets. And I would love to go bindless if hardware support for it was greater, but it's not, right? So, yeah, it's definitely one of the more challenging aspects of it. But, I think this time around I've got it, right? Because this makes very few assumptions and essentially becomes a little bit more of a pass-through directly to Vulkan. And the other, at least from what I've looked into, the other backends such as Direct3D and Metal work similar enough to this where mapping it over to those is not going to be a big deal. Does make a lot more sense. Appreciate you taking the time to break it down for us. I lean towards system design, so this kind of breakdown is pretty cool for me. Awesome. I'm glad it helps. Thank you for the follow. Appreciate that. Very hard. Yeah, it is. It's difficult for sure. Better understanding of the full system as opposed to learning each part of it as you add in. Yeah, I see what you mean. Yep. For sure. Yeah, so that's kind of the reason that I thought about this stuff online, but like even as I'm kind of talking my way through it, it's like one of the benefits of streaming, actually, believe it or not, is rubber ducking. right? So instead of talking to one of those rubber ducks that I have back there, I don't know if you guys can see them. Instead of talking to one of those, I talk to you guys, right? Dingus ducks. I actually don't have a duck that says dingus on it yet, but I'm afraid to Google that also. I don't know that I want that. I don't know that I want that in my my search history. Seems a little rubber dingus, yeah. That seems a little risque there. Who knows? Yeah, I just,
So forget about it, cuz.
that. All right. First time chatter, welcome. Good luck, please. I want to learn programming language C, but I don't know where to start. At least get a rubber duck emote. I do have one. Well, kind of. There's that one. Not quite the same thing, but I might be out of emote slots. I have to look. I could add a rubber duck one, though. Let's see. So you don't know where to start to learn C. So I can kind of answer that question. Now, this isn't necessarily the only book that I would recommend, but this is the book that I learned initially how to write C. So this is C in 24 hours. Teach yourself C in 24 hours, rather. And this is by Sam's, right? So it's I don't know if there's, it's by Tony Zhang, right? So this is basically 24 like cumulative hours. It's not like in a day, right? But this was pretty good. I used this to kind of pick up C initially. I forget when this book was actually published. It's quite old now, but it was pretty good. And then, of course, the best way to learn any language is to actually, use it. Oh God. Okay. 1997 is this one. So yeah, there's probably something newer out there, but that's the one that I usually. La Foley. That's funny. But yeah, what I usually recommend to people if they're wanting to learn and get good with writing C is to, once you understand the basics of the language, write a string processing library that would be functionally equivalent to what you might get in one of the higher level languages, like C# or Java or JavaScript, one of those that have all the the mid and the trim and the format functions and all that stuff. Write that stuff completely from scratch, not using the standard library at all. If you do that, you'll be good enough with C to be able to write a game engine with it. Guarantee it. Okay. I ask my dog coding questions all the time. Bad thing is, she thinks all my ideas are good and she just constantly wags her tail. Yeah, I get that. I've tried it. It doesn't work anymore. I mean, it works once or twice, but, beyond that, it doesn't really work. My dog just sits there and looks at me and farts, basically. Let's see. Or Modern C from Gestet, who is on the community. Yeah, I mean, that's another thing, I do usually say learn like C99 first, right? Or C89 or C99. Learn that first and then learn the more modern stuff. Your dog's a vibe, yeah. Yeah, she is. I love her to death, but, she walks in here every once in a while and just crop dusts me and about bowls me over, I hear that alarming little ptss, and I'm just like, oh boy, I need to exit the premises, That is thick. But anyway, yeah. Recently discovered string token. It's so good. Yeah. I mean, it is and it isn't, right? Because it's not thread safe. So there's that. It has, it's got a weird internal static state. that can bite you if you're not careful. So I used to use it a lot, but yeah, I don't use it because of that. I don't use it all that often. There is string toke R. Yes. I don't think I've used that one though. Is that a thread safe version? I don't think I've used that one. String token is awesome, but you have to string duplicate your stuff or it will touch it. Yes. Yep, that too. Yeah, it modifies the string in place, which is also kind of annoying. Okay. Where was I? Okay. I guess this is probably all we need for the binding set use state. Let's see. Vulkan shader frequency info. So this is specific for UBOs. I'm actually wondering if we need this at all. We do have... See, there's all this uniform count stuff that we need to get rid of as well. We do have the UBO size and the UBO stride here. And the offsets. But don't we also have the offset? We do have the offset here. Maybe we should rename this to UBO offset. I'm kind of wondering if we actually need this at all. Uniform sampler count, we don't need that. We have sampler indices. And those are the samplers, those are the global sampler indices. So we do need those texture indices. So we do need those, but why couldn't we just keep that in here? I feel like we might actually be able to get rid of some structures here. Let's get rid of the sampler count first. Let's get rid of that stuff because that's we want to remove samplers entirely. Actually, let's take a look at the shader real quick, and maybe that'll give us some hints as to how we need to actually reconfigure this. Okay, so descriptor set count. Descriptor set count is going to be the binding sets count, right? So we have that. This is descriptor set config, which is now Vulkan shader descriptor set layout count. We don't have this anymore. We deleted that. So this is actually going to need to be an array. Whoops. What am I doing? An array. Max of 3, that's not true anymore. Let's see. Array of descriptor sets. And then we could also say matches binding set count. Right? So I guess I'm trying to decide if I want to actually make the terminology of this match the whole binding set thing that we've got going on. But I don't think I'm going to. I think I'm going to keep this as is. Okay. Count matches binding set count. Okay, so attributes, we have to keep that. Uniforms. Okay, so shader uniforms. These are going bye-bye. They do not exist anymore. So uniform count and uniforms, gone. Attribute stride, that needs to stay. Face cull mode. I don't think we actually read this from here anymore. That's part of dynamic state. That shouldn't even be in here. Topology types for the shader pipeline, that needs to be here. Immediate size, we just added that. Let's see. We probably ought to have, instead of max groups, we're going to have max use count. Right, so how many... Oh, wait a minute. Wait. No, that doesn't belong there. That belongs... Does that belong here? I don't know if I want to keep it with the config. It's more states, which is separate from config. Let's see. Okay. Yeah, this is probably where it should be. So technically what we need... This is going to be binding set use state. We need a binding set state that has the max use count, and then it has these things in it. So what we actually need is a binding set state. So what we need is this. This is the missing piece that I couldn't think of. So we'll put this here. And we're going to type def this. So we'll say Vulkan shader binding set states. And then we'll have U32. What did we say? Max use count. And then we'll have Vulkan shader binding set use state. And I guess we could put uses, right? And then we'll say binding set state per use, right? Total number of uses. Array size equals max use count. Okay, so this is what we're going to want in our down here. So we'll do binding set states, right? And then we'll have a U32 binding set count. If I can type. Yeah, number of binding sets in the shader. Get rid of that. Now, descriptor set layouts. This also had a max of 3. However, it's kind of dumb to have them here. That should probably be in descriptor set config, which, don't we actually already have? That's layout binding. That should probably be. This should probably be here. Right, so descriptor set layouts. Oh, wait a minute. This is the... Wait a minute. Descriptor set config. No, this should be next to that, not in it. Right. This should be an array set like this. Descriptor set layouts matches binding set count. Yes. Okay. That makes sense. Okay. Let's see. What else? Stage count. Okay. Stages. We need that. All right. So descriptor pool sizes. That is going to be... We might have to increase that too. I might come back to that. In fact, I'm going to put a fix me in here. All right, the descriptor pool for it, that's fine. Uniform buffers per image, that's fine. Pipelines are fine. Bound pipeline index, that's fine. Binding set count, here's the binding sets. This, actually, now that I'm thinking about it, this probably ought to sit up here next to this. And we might actually want to... We don't need this because we can actually use descriptor set count. Matches binding set count. Right. So this is going to be, yeah, okay, that makes sense. So we'll combine those two guys so we don't have two separate counts floating around. Shader frequency info, we're going to delete those. Required UBO alignment. So this is what I was talking about before. I've even got some notes in here. The amount of bytes that are required for UBO alignment. This is used along with the UBO size to determine the ultimate stride, which is how UBOs are spaced out in the buffer. Example, blah, 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 blah. 256 means the stride must be a multiple of 256, right? True for some NVIDIA cards. So this is actually directly what I was talking about before with that. So we are already taking this into account. So that obviously needs to stay there. And then shader flags. Okay, so that all makes sense. That is fine. Let me see. I could have swore I saw some errors up here. Okay, so let's see. Sampler state. So we have the uniform here. I probably should not have gotten rid of... Probably should not have gotten rid of sampler state too quickly. Because what was in that? Let's see. Name, offsets. Don't need either one of those. Location, texture sampler index, size, frequency, uniform type, array length. Okay, this is the only one I think we need to keep. Okay. Is array length. So, oh wait, I think it was Vulkan types we were looking at. Yeah. So when we're looking at this, instead of uniform, all we really need is, you know what? I'm gonna cut this down to a U8 and say array size. I'm actually just gonna move this down here. And so what this is representing is like if the sampler is an array, like a sampler array, that's what this is used for. I guess we could also do we have sampler type? We don't. Do we have... It was just uniform type, I think is what it was. So we're going to get rid of shader uniform type, and we're actually going to have a... Oh, we only have sampler down here. We do need to know this info, right? So the texture type or the sampler type. I could have swore that we actually had that in here somewhere. Apparently not. I could have swore we had... I know we have it, obviously, in our shaders. I could have swore we had an enumeration for this. Apparently not. Alright, so I guess what I'll do is type def enumeration, and we'll do shader texture type. Right, and I'll take these. And I'm actually just going to remove the word uniform out of here. And I'm actually going to remove... the sort of predefined indices in there, because we don't really need those. Alright, so we have texture type, and we'll do sampler type as a separate thing. If I can type. And then, oh, this should be shader. Wait. Yeah, this is wrong. This should be that. Right? Then we'll do this. We'll copy this down here. And then instead of texture type, we'll do sampler type. And then we'll get rid of that guy. There's a bunch of stuff with underscore R appended to it that seem like good improvements. Yeah, that makes sense. String token uses a static buffer while parsing, so it's not thread safe. Use string token R if this matters to you. Yep. Okay. I knew there was something with that, for sure. Gonna head out for the day and look into starting C. Awesome. Good luck. Takes an out param for the string position, so I would think it doesn't need internal state. You would think. C biting you due to weird things. Say it isn't so, right? String token is awesome, but when you have to... Oh, wait. I already read that one. Yeah. Okay, cool. I did catch up. Gotta go grab dinner real quick. Looks like you're on a solid trajectory. Best of luck to you, man. I appreciate it, Dustin. Much appreciated. Have a good one. Jeet, how are you doing there over on the YouTube side? Hope everything's going well. What are your thoughts on Zig? I don't really have thoughts on Zig because I haven't used it. It's one of those languages that I think would be neat to try, but I'm way too far into development with this to think about even switching. Odin, if I'm honest, interested me more than Zig, but yeah, I haven't tried either one, so I can't really speak on it, to be completely honest. I don't feel like I'm qualified to give an opinion on there because I haven't really used it in any sort of depth. I would probably want to write some sort of renderer in each one of those languages to really get a feel for the language, because that's a big enough project. I feel like by the end of writing that, you would have a pretty good feel of whether you liked it or not. some of Zig's syntax looks a little weird to me, but maybe that's just me being a boomer or something. I don't know. +1 to Zig from me, haven't used Odin. Fair enough. Yeah, see, and that's the thing. It's all about your experience with it, for sure. Let's see. Planning to build a flame graph in Zig for learning. Yeah, that's not a bad idea either. For sure. Mahmood, how's it going over there on the YouTube side? Good to see you. I am well. Thank you for asking. How are you? Okay, so I was adding these in here. So that way I can do shader sampler type. And texture type. Right? Because all the information that we need from either of these is those two things, and we can build the correct descriptor or whatever it is that we need from that information. I'm not even convinced that we necessarily need to know this, but it might help in some cases. Okay. In fact, this will probably help more than anything else because we'll be able to determine if it's like a cube map or something like that, right? You're good? I'm glad to hear it. That's awesome. Welcome. Okay. So I think we might have the binding set state done. Okay, so this frequency info stuff, I feel like this is also, all of this, I feel like it really, because this was more like info on how that particular shader frequency was set up, but not necessarily state, but I feel like we could combine the two. So I think what I might do is actually literally just do that. I think I'm going to combine these two. And I guess I'll do that, right? Okay, so bound ID for this frequency. I don't know that we even need to do this anymore because we had this sort of flow in our program where we would go through and sort of bind the frame info, upload the frame info, apply it, and then figure out what group info we were in, bind that, apply it, do the same thing for per draw, bind it, apply it, and then we'd move on to the next draw or the next group if needed and just repeat that process, right? And it was just kind of this tiered system that we went down. But the way this is going to work is we're not going to be doing piecemeal updates like this anymore. For the most part, right? So the global binding set, everything's going to be applied all at once. So we'll apply the entire UBO at once, the entire transform set of data for the entire scene all at once. Same with the lighting, all at once. Same with the materials, all at once. And so the only thing we'll really have to rebind is like things like textures, right? So I don't think this concept of binding actually makes sense anymore at the sort of frequency level. I think we can literally just say, set this data, at for this particular binding set at the particular binding that we're talking about, right? So we say in this binding set, we want to set the texture at array index 0, right? Or whatever. I don't think we have to do any sort of binding for that. I think we can actually do away with all of that. So the only thing that I can think of that maybe we should probably move over out of this is the UBO size and stride. We already have the offset up here. So we can just keep that. And then pretty sure we can just get rid of this as well. Okay. So I think in terms of how our data structures are going to look, I think that's pretty much it. Oh, max uniforms. We don't need this anymore. We're not dealing with the uniforms anymore. Anything in here with uniforms in it, we are getting rid of. Let me see. Still in school. Where do I learn the math needed for PBR and generally graphics programming related math in order? I don't want to wait until I learn them at school, but I feel stuck. That's fair enough. So you're going to want to learn linear algebra first, right? So that's like vector math. Khan Academy is a great place to learn that online. It's free, and honestly, it's a really good resource on teaching you how all that stuff learns. You're going to need that as a foundation. Once you have that, then there are all kinds of resources that you can look up. PBR, pipelines and how to actually write that stuff up. The one that immediately comes to mind is Learn OpenGL. Has a really good explanation of that. I have an explanation of it here as well. We kind of went through a lot of that on here as well. But I didn't go quite in depth as Learn OpenGL did, just for time's sake, right? But yeah, that's you'll probably want to also look at some other examples of, write-ups on how some of the other game engines do it as well. And look up, read various papers on it, that kind of thing. Yeah, it is going to look like gibberish to you if you don't know basic linear algebra. Yeah, that's why I'm saying you're going to want to get somewhat decent, or at least a working knowledge of that first. What is shader update frequency? Is it hot reload? No. So shader update frequency is, it's actually a thing that we're kind of replacing, but it's basically how often a particular set of data gets updated within a shader, right? So does it, are you setting this particular field once per frame, or are you setting it once per material, or are you setting it every single time you draw something, right? That's basically what that's about. Why not make a tool to automatically generate the data on the right side of the screen? It looks to me like it can be automated if it's only material structure data. So this, what's on the right side of the screen is essentially a plan as to what we're going to build, right? It's kind of a loose spec, if you will. And so, this is kind of you can think of this as kind of a blueprint of what's driving the structure of all the changes we're making here. And ultimately, this is kind of what the shader configuration is going to look like. So we could have stuff that generates this, and eventually we might do so through shader reflection, but we're not there yet. So this is basically what tells Vulkan how to set up its descriptor sets, and what they're all individually used for, and the bindings are used for. Yep. Why is shader update frequency needed? Because you only update certain sets of data at certain times within a frame, right? So, like your projection matrix, right? You don't want to have to be setting that every single time you go to draw something. You set it once for the frame, and then you just are able to reuse that data, right? And so with something like OpenGL, that's a little bit abstracted from you, but from something like Vulkan, you actually have to you have to allocate memory and allocate descriptor sets to update that data individually, right? And you can only do that once per frame. So if you have to update something multiple times in a frame, you have to update multiple descriptors for that. So it's all about memory allocation and how often you're doing it, and you want to optimize that as much as possible. Can't even, wait. Why is it needed? Yeah, I mean, I just kind of explained that. You can't even set uniforms and forget about it in Vulkan. I mean, not directly, right? I mean, we have a system here that we set up to do that. But it's kind of overkill, to be completely honest. It's much more efficient to just throw a struct of data or, you know, a block of memory over at the GPU all at once instead of setting individual things like you do in OpenGL. So it's about efficiency. I like both Zig and Odin. Zig reminds me of somebody trying to improve C, while Odin is very C-like, just with Pascal syntax. That's fair. Way more partial to Odin, though. Yeah, that's fair enough. That seems like that kind of aligns with what I've gotten from a very high-level overview of both. 3 blue, 1 browns. Linear algebra videos are pretty good. Yes, that's another resource for it. I'll put this over here for you on YouTube. Check out that channel right there. There's lots of good math stuff on that one too. I've recommended that several times on this channel for sure. Okay. So with that said, he says thank you to you, Laturo. All right. So with that said, it is actually time for me to end tonight because I do have work in the morning. So I am going to pick somebody to raid. And I just want to say, while I'm picking somebody to raid, thank you guys very much for being here and following along and interacting. I appreciate you guys very much. And if you haven't done so already, I would greatly appreciate a follow, either on the Twitch side or the YouTube side, or both if you're so inclined. I am trying to grow the channel, so I do appreciate each and every one of those. Let me see if I can find something that is loosely related to what we are doing over on the Twitch side. Let's see. Sometimes it's difficult to find something this late at night that's kind of related, but hopefully we'll find something. I've got some backup options if we don't. Just bear with me just a minute here. Okay. Okay, I think I know what I'm going to go with. We're going to raid Jitspo tonight. We're going to see what he's up to. Looks like he is he's doing some he's doing some Go.engine dev. He's making a pretty kick-ass looking retro FPS. It's a pretty neat looking project. So we're gonna go over to him and see what he's up to. And thank you guys so much for being here, and I will catch you guys on the next one. See ya.